First process you need to do is figure out what size bolt and what pitch thread you have on that bolt. So basically, if you don't know, you can take your bolt that you have and you can find out what it is. We have an imperial and we have metric gauges here that you can go ahead and screw your bolt in, and that will tell you exactly what that pitch and diameter is. Once you figured out that, we need to go over and find what's known as the tab drill for that specific thread, because the hole that you need to make needs to be smaller than the diameter of the screw or bolt that you're using. The tap will make it the right size. So our gauge says that we have a 1/4 20 bolt that we're going to be using, so we come over here and we look for the tap size. There's our 1/4 20. We go to the left and it tells me at drill size I need a number 7 drill to drill into the parts that I need to thread. Anything that's close to it would work, but you don't want to go too big because the percentage of your thread engagement is less and likely it could fail. You also have your metric tap drill chart here as well, so if you have a metric bolt, you have all that information here. Now, here it doesn't tell you if it's a 7 drill or a letter or a number or a fractional drill. You'll have to look for the decimal equivalent. Let's just go with an M7. It's a 236 drill, so we come over to the charts and we look for 236. Well, we got a 234, 238. So either one of those two drills would work for an M7.
So there's no such thing as a metric or imperial drill set?
There is a metric drills. There are metric drills, but we just don't have that many here in the shop.
So we work in imperial.
We work in imperial. You also have your pipe threads down here in case you needed to tap threads for pipe fitting and so forth. So there you have it. Okay, so what we have in front of us now is what's known as a drill case. Basically, it has 3 different sets of drills in it. It has what's known as number drills. Over here we have letter drills, and here we have fractional drills. 1 through 60, A through Z, a 1/16 up to a 1/2 inch by 64ths. Under each number, letter, and fraction is the decimal equivalent to that diameter. Okay, now earlier we went to a drill tab chart on the wall, but if you have a drill case, sometimes they will give you that information here. As you can see, we have what's known as a tap drill. Over here we have what's known as a body drill, and here we just have tap drills. So anything smaller than a 1/4 inch, they gave it a number, from 0 up to 12. And anything bigger than a 1/4 inch, it goes by fractions. Okay, so what's a body drill? Great question. Body drill is basically a clearance hole. Let's say you had 2 parts that you needed to bolt together. Well, you can't have threads in both pieces because where the threads exit on the one part and enters into the next part might not allow you to align that part the way it needs to be. So you put basically a clearance hole in the top piece where that screw, bolt, whatever it is, that fastener goes straight through without any interference. Now, when you ever come into the shop, sometimes students will just put drill bits back wherever they fit. So earlier we did a 1/4 20, so I needed a number 7 drill. So I can come over here and grab my number 7 drill. On the shank of the drill, it should be marked what it is. That's an easy way of making sure you have the right drill. If you can't see it, especially with the smaller diameters, you can take a dial caliper and measure the flutes of the drill. So basically what I do is I'll close it, then I'll twist my drill, and I'll look at my dial to see where it ends up. So basically that's 2.02. Number 7 drill is a 0.01201. So that is a number 7 drill. Okay, so what we have in front of us are a set of taps, and we also have what's known as a machine tap. The set of taps always comes with 3. So basically what you have here is what's called a taper, plug, and bottoming tap. If you notice at the beginning of the tap, the lead right here, there's very little threads at the very bottom. If we go to the plug tap, we start to see more threads being formed towards the bottom of the tap. and the bottoming tap, you have threads pretty much at the bottom. So basically what happens here is you start with this tap, go with the middle tap and finish with the bottoming tap if you have what's known as a blind hole, where the hole does not go all the way through the part, because this will get your threads at the bottom of your hole. Now if that hole goes all the way through the part, you can go ahead and just use the tapered tap first. You don't need to use any of the other ones. Now this machine tap here, basically that's designed to be put in the machine and let the machine do the work for you. Well, typically we don't want you guys putting them in the machine. We want you guys to manually tap your holes when you're here in the shop. Okay, now every tap is ground square at the top and every tap is marked exactly what it is. Now, when you're doing this, each thread has two pitches, a coarse pitch and a fine pitch. So you'll find that out when you're using the gauges over there if you're not sure what that bolt is that you're using. So now what happens with the square end of the tap, you take what's known as a tap handle, and they come in different configurations. Okay, we call this a T handle, and this is just a normal tap handle. So basically what happens is you take the square end and you put it in the corner of the handle, and then you just tighten up that handle onto the tap. And that gives you the ability to turn that tap into your material that you're trying to thread. If you didn't, and you were using a hard piece of material, that tap wouldn't rotate, but the handle would rotate on the round shaft. Okay, now the other one here, you basically just open up the collar, insert the corners into these, and tighten it down. Okay, so let's say you drill the hole on the drill press and you don't have the luxury of using the milling machine. So you can tap a hole without a center. You basically are the center. So basically what you need to do is you need to put pressure downward as you turn it clockwise, and once the tap engages the material, it'll draw itself down, because obviously it's a screw that has sharp cutting edges. Don't forget, add a little bit of cutting fluid. Now, the big thing here is making sure that tap is going straight into that hole. So basically you have to look and make sure it's perpendicular in this direction and this direction. So if it isn't, you have time to manipulate it until that tap is fully engaged. Once it's fully engaged, whatever that angle is, it is. After about 1 or 2 full revolutions, take it back about a half. You'll feel a chip in there break. Once you feel that chip break, go ahead and continue on. 1 full revolution, back about a half. Now with a 4-flute tap, and that's what I shown you earlier, the bigger taps, they kind of center themselves, so you really don't need to worry about making sure they're perpendicular in the X and Y. You just have to put pressure down until it engages the material. Okay, we have another hand tapping device that you can use to make sure your tap is going straight into your hole if you don't want to do it, obviously by hand. So basically it has a vise, so what you can do is make that vise open, bigger than what it needs to be. Take your screw, just to lock it in place. It's just holding it so you don't have to hold it, because you're trying to hold that part as you turn this handle, something's not going to turn. Okay, so now what we need to do is we need to find a collar that fits the tap that we are using. I believe this is it. So basically what you'll need to do is just go ahead and insert it. It'll seat itself. Once it seats itself, there's a little set screw right here that you can go ahead and tighten down so the tap doesn't fall out of the collar. Then you're going to go ahead and insert it into the apparatus, align the tap to the hole, and now you can go ahead and slight pressure down. Turn that handle until it engages. Once it engages, back half and then continue on. Okay, so once you have your hole drilled, you should always chamfer the top of your hole. What that allows is the tap to start the threading process nice and clean, so when you have your bolt, it has a nice clean entrance into the part itself. The part that I'm putting in the drill chuck right now is what's known as a spring-loaded center. What that's going to be able to do is keep our tap nice and perpendicular, both in the x-axis and in the y-axis. So you can just go ahead and put that in by hand, doesn't need to be tight. We have our tap and our handle, and at the top of the handle, we have a little area for the center to go into. So basically what we'll do now is lower the quill, put some pressure on the spring-loaded portion of the center, and now what we can do is go ahead and rotate our handle and tap our hole. Now when you're tapping a hole, you have to be careful. Smaller the diameter, the more fragile they are, and the easier they are to break. The bigger the tap, not so easy, but they will break. They're hardened material, they will shatter, and you just have to be very careful. You should add some cutting agent on it. We have cutting fluid here in this little tub. Just add a little to it. Now, after about one or two full revolutions, take it back about a half. You'll feel a chip in there break. Once you feel that chip break, go ahead and continue on. And after, again, one full revolution, go back about a half, break that chip. If you don't break that chip kind of gets tangled up inside there, then it's really difficult to bring the tap out. Once you've fully unthreaded your part, you can go ahead and disconnect your quill, and then you can go ahead and take your tap out and go to the next hole if there is another.